We're looking at this question this time, and we've got a van going around a bend, and we've got a simple pendulum that's hung from the roof. So imagine one of those little things hanging from the roof, a little fluffy dive or something like that. And you've got the van rounds a bend at 54 kilometres an hour, and once it does that, the pendulum makes a 20-degree angle with the vertical. So what does that look like? Well, there's your verticals there, and your little fluffy dice moves out at a 20-degree angle. We want to find the radius of the bend. So basically, what's the bend? What's the radius of the bend that it's traveling around? So our velocity is 54 kilometers an hour, which we need to put in meters per second. We can start to play around. We know what our forces are doing there. We know with supposing mass times gravity, we know mv squared OR would be opposing what's in the center. So solve them vertically and horizontally. We get the t cos 20 degrees is mass times gravity. And t sine 20 degrees is mass times the velocity squared on r. So we've got we've solved them horizontally, we've solved it vertically. Now to get our radius, well, we need to find our radius here. We need to eliminate t. We don't know what the tension in the string is. We haven't got enough information there. We don't have a mass as well. So we need to eliminate a few things. We know what the gravity is. We know what our velocity is. And obviously we had our 20 degrees. So we want to find r. So if we take the equation 2 divided by equation 1, so the t's cancel and we get tan of 20, and the mass cancels and we get v squared on rg, which is okay because we want to find r, so we get r by itself, so multiply by r and g and divide by r20, or we could have just left a g down there, and the velocity is equal to g times tan of 20, and taking gravity is 9.8, we're able to work out that our radius is 63.1 once we put our values in. So there we go, that's how we solved that question. Again, back to solving them vertically and horizontally. This time we got two particles. One's of mass 2m and one's of mass of m, and they're connected by a light inextensible string, so it's not going to stretch on us, of length a. So the string there is length a. So there's our two particles. The string passes through a fixed smooth ring, so it's fixed and it's smooth, so there's no friction. And 2m hangs in equilibrium. So what basically that means that it's going to just hang there. It's going to hang, and the other mass, just of m, is moving in a horizontal circle around with angular velocity of omega. What we want to do is find the inclination of the moving string to the vertical, so find our angle there, and show that omega squared outside of a minus x is equal to twice gravity. Okay, well, how do we do that? Well, we know there's tension in the string there, and that must be the same tension that's in the string there. So our mass is hanging there. We've just put it there, and it's hanging. So the tension's going up that string, and say it must be in equilibrium with that one there. But it also must equal twice the mass times the gravity. So we solve them vertically. T is equal to 2 times m times g. We also have situation here that, well, that's solving section 1. And because it's only just hanging, there's no horizontal movement. This one's got horizontal movement. This part's swinging around. So it's got a horizontal movement. But it's also going to be solved vertically as well. So if that's going to be theta there, so we want that angle theta there. So our angle there would be theta. So we could solve it vertically there because that would be t cos theta. And that would be equal to mass times gravity. So those two are in equilibrium vertically. But we also know that t is equal to twice mass times gravity. So we can do that substitution. And so 2 mass times gravity times cos theta, the mg cancels. Cos theta is equal to half, and allows us to get theta being equal to pi on 3. Well, there's our angle. So they're solving these ones vertically in section 2 here allows us to get it allows us to get it equal there. So next part, we want to solve them horizontally. So we know that t sine theta, so t sine theta is equal to mass times omega. So t sine theta is through there. Mass times omega squared times r. So they're equal. We're going to sub in T is equal to twice mass times gravity, and theta is equal to pi on 3. So we do that substitution. Our mass times gravity mass cancel, sorry, there. And we sine theta pi on 3. It gives us the root 3 on 2, so our 2 will cancel with that. And then so divide by r, and we get the gravity times root 3 there is equal to, and divided by r is equal to omega squared. So we're able to get that situation. Now, we do also know that in this triangle, if we just bring out that triangle by itself, that height there would be equal to a minus x. Now we get a minus x there because that's the length of the string there, but that's x there, and the whole string was of length a. So the length of this from a to p here would be a minus x, because that's a distance, because it hangs the distance x below. So that's where the a minus x comes from. We had our radius and we had our height, so we know we can get sine of theta is equal to r on a minus x. And then we can say that r would be a minus x times sine of pi on 3, because theta is pi on 3, gives us a root 3 on 2 a minus x. So from that, we know that omega squared, from what we just had when we solved them horizontally, omega squared was root 3 on g times r, divided by r, and that's what we can put in for r. And then we can start to clean it up. The root 3's will cancel, and we get gravity divided by 2 there, and it's divided by a half, which gives us twice times gravity, and the a minus x can multiply across, and that's how we get our solution there. So that's what we're looking at. There's our values there, but notice all these questions, we're starting to have mass times gravity, and that's how we're starting. I'm sorry, they solve them horizontally and vertically, and vertically it's going to be equal to whatever the mass is times the gravity, and whatever the we get horizontally, it's mass times omega squared times r, or mv squared on r. So we solve them horizontally, solve them vertically, and that's how we start to do all our problems, and we start to work out what we need.